Hello, Grade 8 learners! Welcome sa isa na namang episode na punong-puno ng kaalaman. Mundo ng numbers ating niyang pag-uusapan. Kaya ano bang hinihintay nyo? Halina't MATH-TUTO! Are you ready for a fun-filled discussion? By the way, I am your math teacher for today, Ma'am Madeline Guy. Get your learner's packet, answer sheet and ballpen, and stay tuned in another exciting Grade 8 Mathematics lesson only here in HALINA'T MATH-TUTO sa Dasmariñas North National High School.
Welcome to Lesson 1 of Math 8 Quarter 2, Linear Inequalities in Two Variables. We have the following lesson objectives. Differentiate linear inequalities in two variables from linear equations in two variables. Illustrates and graph linear inequalities in two variables. Solve problems involving linear inequalities in two variables. Let's recall what we have learned in the previous lesson. In the previous lesson, we have learned about linear equations in two variables. It is written in the form ax plus by equals c, where a, b, and c are real numbers and a and b are both not equal to 0. The highest degree of exponent is 1. The graph is a line, and the solutions are ordered pair xy that satisfy the equation. Let us now differentiate linear inequalities in two variables from linear equations in two variables. The given table shows how can we differentiate linear equations in two variables and linear inequality in two variables. So, for the symbol used for linear equation in two variables, we use is equal to symbol. For linear inequality in two variables, we use is less than, is greater than, is less than or equal to, is greater than or equal to symbol. For the standard form, the linear equation in two variables, we have ax plus by equals c. For the linear inequality in two variables, ax plus by is less than c, ax plus by is greater than c, ax plus by is less than or equal to c, ax plus by is greater than or equal to c. The graph of a linear equations in two variables is a line, while the graph of a linear inequality in two variables is a half plane. The solution, all points x, y on the line is the solution of a linear equations in two variables. For linear inequality in two variables, for less than and greater than symbol, all points x, y in the shaded region only, and for less than or equal to and greater than or equal to symbol, all points x, y in the shaded region and the boundary line. The graph of a linear inequality in two variables is the set of all points in the rectangular system whose ordered pair satisfies the inequality. When a line is graphed in the coordinate plane, it separates the plane into two regions called half-plane. The line that separates the plane is called the plane divider or the boundary line. Let's try graphing. For example 1, graph the solution set of 2x plus y is less than 4. For step 1, replace the inequality symbol with an equal sign and solve for the intercept. The given inequality is 2x plus y is less than 4. It will become 2x plus y equals 4. Then, solve for the x and y intercept. For the x-intercept, we let y equal 0. So, substituting 0 to y, we have 2x plus y equals 4. So, we have 2x plus 0 equals 4. So, 2x equals 4. We divide both sides by 2 to solve for x. So, we have x equals 2. The x-intercept is 2, 0. For the y-intercept, we let x equals 0. So, 2 times 0 plus y equals 4. So, y is equals to 4. So, the ordered pair or the coordinate of the y-intercept is 0, 4. Step 2, graph the resulting equation. Plot the x and y intercept. The x-intercept is 2, 0 and y-intercept is 0, 4. Given the Cartesian plane, plot 2, 0 and 0, 4. Now, draw the plane divider or the boundary line. If the inequality contains less than or greater than symbol, use a dash or a broken line as boundary line. It means that the coordinates of all points on the line are not part of the solution set of the inequality. If the original inequality contains less than or equal to or greater than or equal to symbol, use solid line as boundary line. It indicates that all points on the lines are part of the solution of the inequality. Since the given inequality uses less than symbol, we will draw broken line as boundary line. For step 3, use the origin 0, 0 as testing point and substitute it to the given inequality. If the testing point satisfies the inequality, shade the area where the origin is located. And if not, shade the other side. So the given inequality is 2x plus y is less than 4. Substitute 0 to x and 0 to y. So it becomes 2 times 0 plus 0 is less than 4. So we have 0 is less than 4. Is 0 less than 4? It is true. Since the testing point 0, 0 satisfies the inequality, we will shade the half plane where the origin is located. The solution set of the given inequality includes all the points located at the shaded region. We have to notice that since the boundary line is a broken line, all the points located in the boundary line is not part of the solution set of the given inequality. Some of the ordered pair that belongs to the system of inequalities are 0, 1, 1, negative 2, negative 3, 3, negative 4, negative 6, 1, negative 6, and many more. Let's try example 2. Graph the solution set of 2x plus 3y is greater than or equal to 6. For step 1, replace the inequality symbol with an equal sign and solve for the intercept. So the given inequality is 2x plus 3y is greater than or equal to 6 becomes 2x plus 3y equals 6. Then solve for the x-intercept. We let y equals to 0. So it becomes 2x plus 3 times 0 equals 6. So 2x equals 6. Dividing both sides by 2, we have x equals 3. So the ordered pair of the x-intercept is 3, 0. For the y-intercept, we let x equal 0. So it becomes 2 times 0 plus 3y equals 6. So 3y equals 6, dividing both sides of the equation by 3. So we have y equals 2. So the y-intercept is 0, 2. For step 2, graph the resulting equation. Plot the x and y-intercept. The x-intercept is 3, 0. The y-intercept is 0, 2. Given the Cartesian plane, plot 3, 0 and 0, 2. Now, draw the plane divider or the boundary line. If the inequality contains less than or greater than symbol, use a dash or a broken line as boundary line. It means that the coordinate of all points on the line are not part of the solution set of the inequality. If the original inequality contains less than or equal to or greater than or equal to symbol, use solid line as boundary line. It indicates that all points on the lines are part of the solution of the inequality. Since the given inequality contains greater than or equal to symbol, the boundary line is a solid line. It means that all the points containing the line or located in the line are all part of the solution set of the given inequality. For step 3, use the origin 0, 0 as testing point and substitute it to the given inequality. If the testing point satisfies the inequality, shade the area where the origin is located, and if not, shade the other side. So, substituting 0 to x and 0 to y, we have 2 times 0 plus 3 times 0 is greater than or equal to 6. So, we have 0 is greater than or equal to 6. Is 0 greater than or equals to 6? So, it is not. So, the statement is false. Since the statement is false, we'll shade the half plane that does not contain the origin 0, 0. The solution set of the given inequality includes all the points located at the shaded region and the points in the boundary line, since the boundary line is a solid line. So some of the ordered pair that belongs to the system of inequalities are 0, 2, 3, 0, 6, 6, 4, 0, 1, 6, and many more. This time, let's try to solve problems involving linear inequalities in two variables. Here are some of the words. that you may encounter in a word problem and the inequality symbols appropriate for them. So if we encounter less than, we use the less than symbol. If we encounter greater than, more than, is over, exceed, we will use the greater than symbol. For the less than or equal to symbol, we may encounter at most, no more than, not exceed, has a maximum value. And if we encounter the word at least, is not under, has a minimum value, we will use the symbol greater than or equal to symbol. Let's have the sample problem. Maria bought 4 kilograms of flour and 3 kilograms of brown sugar and paid not more than 463 pesos. If a kilogram of brown sugar is 45 pesos, then how much is the cost of the flour? So for step 1, formulate a mathematical representation of the given problem. So we let X as the flour. For Y, we let Y as brown sugar. Therefore, we have the inequality 4X plus 3Y is less than or equal to 463 since we encountered the word not more than. So we will find the cost of the flour X. So step 2, solve the problem using the mathematical representation. So we have the given inequality 4x plus 3y is less than or equal to 463. So since the cost of a kilogram of a brown sugar is 45, we will substitute it to y. So we have the inequality 4x plus 3 times 45 is less than or equal to 463. So let's simplify. 4x plus 135 is less than or equal to 463. Applying the addition property, so 4x plus 135 plus negative 135 is less than or equal to 463 plus negative 135. So we have 4x is less than or equal to 463 minus 135. So, and we have 4x is less than or equal to 328. So, dividing both sides by 4. So, x is less than or equal to 82. So, the cost of the flour is less than or equal to 82 pesos. Thank you and have a nice day.
Since everything is clear, you may now start answering the learning task of the week. And don't forget to like, share, and subscribe in our YouTube channel so you will be updated in our latest uploads. At ayun na nga, natapos na naman ang ating talakayan. Hanggang sa susunod na linggo, dito lamang sa programang Punong-Puno ng Kaalaman. Mundo ng numbers ating niyang pag-uusapan. Kaya't ano pang hinihintay nyo? Halina! MATH-TUTO!